Menurut The World Happiness Report tahun 2018, Norwegia menduduki peringkat kedua negara paling bahagia di dunia. Hai allesammans, jeg heter Bagja. Hari ini di Garin Tour kita akan melihat perkembangan infrastruktur di Norwegia.
Selamat datang di Stavanger. Semoga terhibur.
Selamat datang di Stavanger.
Sistem transportasi di Norwegia mungkin bisa menjadi pembelajaran buat kita di Indonesia, di mana mereka sudah mengembangkan beberapa teknologi yang aplikatif, yang bermanfaat dan bisa memberikan dampak yang lebih efisien dan juga dengan biaya yang lebih murah. Salah satu teknologi yang mungkin bisa kita lihat adalah angkutan umum, terutama untuk bus, di mana mereka sudah mengintegrasikan sistem pembayaran yang bisa dilakukan secara online tanpa harus dilakukan secara tunai. Juga beberapa fasilitas lain seperti misalnya untuk melihat jadwal angkutan umum dan juga untuk melihat rute tercepat itu sudah bisa dilakukan secara online melalui aplikasi apps. Di sini menunjukkan bahwa hal-hal yang positif bisa menjadi pembelajaran buat kita dan juga mungkin bisa diaplikasikan di Indonesia.
Energi di Norway itu mostly 99% dari hydropower karena memang banyak banget di sini fjell atau gunung. Tapi Norway ini juga salah satu termasuk yang maju dalam industri offshore wind turbine. Jadi banyak banget perusahaan di Norway yang mulai initiate untuk commercialize offshore wind turbines. Bahkan marketnya sampai ke Jepang, sampai ke US juga. Tapi sayangnya offshore wind turbines di Norway itu masih cuma 1 biji, dan itu pun hanya dipakai untuk research. Dari hal inilah banyak banget negara-negara di EU yang protes. Kenapa sih Norway commercialize offshore wind turbines tapi mereka tidak membangun buat mereka sendiri? Nah, tapi untuk target ke depan pemerintah Norway tahun 2020 akan dibangun di daerah Gufax, di salah satu oil and gas reservoir di Norwegian Continental Shelf. Itu akan dibangun wind farm yang akan supply energi dari ekstrak dari energi dari angin, akan diekstrak dan dibawa menuju ke platform itu.
Oslo Adala Ibukota, Norvegia. Di sini moda transportasinya banyak lo.
Oslo sebagai ibu kota dari Norwegia sudah memiliki transportasi yang sangat baik. Ini dibuktikan dengan adanya sistem metro yang sudah ada sejak tahun 1966. Di samping itu, mereka juga sudah mempunyai bus dan juga tram, dan bahkan sekarang di era digital transformasi ini mereka sudah mencoba untuk beralih ke autonomous transportasi, autonomous bus, dan pilot projectnya itu sudah dijalankan dimulai dari tahun kemarin. Selain itu juga beberapa transportasi mereka sekarang sudah beralih ke greener energy dengan menggunakan electric powered vehicle.
Hubungan Indonesia-Norwegia sudah cukup lama. Kita sejak tahun 1950-an awal ya, sudah punya hubungan diplomatik dengan Norwegia, kerajaan Norwegia. Dan banyak orang Indonesia yang datang ke sini, apakah sebagai mahasiswa, apakah sebagai pengusaha, apakah juga sebagai turis yang menikmati indahnya Norwegia, dan sebaliknya juga banyak orang Norwegia yang berkunjung ke Indonesia gitu. Nah, bagaimana potensi baik itu Indonesia maupun orang Norwegia bisa dimanfaatkan, dioptimalkan. Nah, apa yang kita lihat absen selama ini di Norwegia adalah ya kehadiran diaspora Indonesia yang bisa lebih connected dengan Indonesia, bisa lebih memberikan kontribusi buat Indonesia, padahal cukup banyak ya, profesional Indonesia yang ya punya kapabilitas, punya kemampuan, punya perspektif yang bagus untuk membantu Indonesia untuk melangkah lebih maju. Nah, saya melihat misalnya komitmen Norwegia untuk blue economy, ya, komitmen Norwegia untuk green economy, ya, untuk sustainability. Ya. Ini semua komitmen yang bukan sekedar mimpi. Gitu. Ini semua ada ada bisnis yang bisa di-develop, gitu. Bisa dikembangkan di balik itu. Nah, kita juga harus bisa ikut ambil bagian dalam proses ini. Dan saya percaya profesional Indonesia yang ada di sini, di Norwegia, bisa berbuat cukup banyak untuk membawa ya perspektif yang sangat pro lingkungan, sangat pro green economy dan blue economy ke Indonesia. Karena karakteristik geografis Indonesia dan Norwegia itu sebetulnya ya banyak persamaannya dan ya kita bisa mendapatkan banyak hal dari Norwegia dan kita bisa bekerja sama dengan Norwegia. Nah, disinilah peran diaspora Indonesia, disinilah peran komunitas profesional Indonesia yang ada di Oslo, yang ada di Stavanger, yang ada di Trondheim, di Bergen ya, untuk bisa ya melakukan banyak hal-hal yang konstruktif, yang positif buat Indonesia.
Terima kasih sudah menonton. Sampai berjumpa lagi.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi rekan-rekan semua. Alhamdulillah di hari Sabtu ini kita ketemu kembali ya bersama kami di webinar yang ke-13. Itu kita akan membahas tentang file section fondasi ya. Jadi ini sangat bermanfaat untuk industri struktur di offshore ya, baik itu di oil and gas dan juga di wind turbine ya. Dan alhamdulillah di tengah-tengah kita telah hadir para panelis. Yang pertama itu Pak CJ. Good morning Pak CJ.
Selamat pagi.
Selamat pagi. Weekend. How are you?
Very good. Baik.
Yeah.
Ada bagus. From greetings to all. Good morning to all from Kuala Lumpur.
Yeah. Yeah. Now we have around 140 participants. Maybe just 85 just join. So thank you, CJ, for you will share something very important to us. Yeah. So we see mostly the participant come from the engineering company and others. And also di kesempatan ini telah hadir juga Pak Tigor. Selamat pagi Bang Tigor.
Selamat pagi Bagja, selamat pagi semuanya.
Ya, Bang Tigor ini adalah Ketua Departemen dari Sipil Strak di Ikatan Ahli Fasilitas Produk Minyak dan Gas Bumi. Dan Bang Tigor ini nanti akan menemani kita semua sebagai moderator ya, sebagai moderator di acara webinar ini. Dan tentunya di tengah-tengah kita telah hadir juga Mbak Desi. Selamat pagi Mbak Desi, apa kabar?
Baik, selamat pagi. Assalamualaikum.
Mbak Desi ini adalah perwakilan dari IAFMI dan sekarang beliau menjabat sebagai Direktur Eksekutif dari Ikatan Ahli Fasilitas Produk Minyak dan Gas Bumi. Ya mungkin saya izinkan share screen sebentar ya untuk pembukaan. Udah kelihatan ya mungkin screen-nya. Ya, hari ini adalah kita akan mengikuti webinar kita yang ke-13 tentang Suction Pile Technology Innovative Foundation Solution for Offshore, Oil and Gas and Renewable Development ya. Nah, ini adalah CV saya. Saya juga sebetulnya berkiprah di dunia offshore sebagai structural engineer ya, juniornya Pak Tigor, dan saya juga pernah bekerja di Belanda ini di Papendrecht ya. I think CJ will miss Netherlands a lot, I think.
Pak Bagja, ya. Pak Bagja itu yang nampak di layar masih foldernya.
Oh, oke, sebentar. Ya, sekarang mungkin ini ya.
Ya, oke. This one good.
Ya, oke. Ya, saya juga structural engineer. Di tahun 2019 saya pernah juga kerja di Belanda ya, di I stay in Rotterdam, PJ, and I work in Papendrecht, Netherlands at that time. So ini adalah saya juga di foto di bawah bisa dilihat, ini adalah waktu saya di Netherlands. Ya mungkin langsung saja, apa itu Garuda Infrastruktur? Garuda Infrastruktur ini adalah profesional infrastruktur network. Kita sudah menjadi perseroan terbatas ya di tahun 2017, dan kita bergerak di di media sosial kita di Instagram. Kita sudah memiliki 55.000 follower lebih. Kemudian di YouTube juga kita baru 1.500-an ya, karena baru kemarin mulai develop di YouTube ini. Nah, jadi visi kita adalah ingin menjadi infrastruktur network dan hub untuk di Indonesia untuk dari berbagai stakeholder, dengan misi menjadi knowledge dan reference center untuk infrastruktur stakeholder. Kemudian juga ingin menjadi bisnis inkubator, dan yang terakhir ingin mempromosikan infrastruktur capability Indonesia ini
dan juga investment relation. Ya, apa yang sedang dilaksanakan sekarang gitu tentunya belum semuanya kita jalankan visi misi itu, tapi yang sedang jalan adalah baru 2, yaitu yang pertama adalah garin training atau seminar, dan yang kedua adalah garin media gitu. Yang training ini kita konsepnya sedikit berbeda mungkin ya, kita adalah tidak hanya melulu di kelas, tapi ada praktikal di lapangan. Ini sebagai salah satu contoh waktu pertama kali kerjasama dengan IPB, kita melaksanakan training soil mechanic and theoretical class ini diadakan 2 hari di kampus, kemudian di hari terakhir kita ajak peserta lab waktu itu ya, untuk melihat demo bagaimana soil mechanic itu seperti apa. Gitu. Nah, ini kemudian sebagai salah satu contoh tentang ground improvement, waktu itu 2 hari di kampus, di kelas, dan hari terakhir kita ajak peserta ke site ya, ke site di Pantai Indah Kapuk 2 untuk melihat ground improvement itu seperti apa dan aplikasinya bagaimana dari teori yang sudah diberikan di kelas. Dan ini juga yang terakhir sebelum pandemi, ini kita ajak peserta mengikuti training bridge dan training tentang jembatan. Kita waktu itu 3 hari di Universitas Pertamina, dan hari terakhir kita ajak semua peserta ke Karawang untuk melihat case product dari dari jembatan itu apa aja sih, seperti itu. Nah, ini adalah asosiasi yang sudah berkolaborasi dengan kita, dan di sini juga saya tentunya berterima kasih kembali kepada Mbak Desi dan tim, karena dengan IAFMI kita udah ada MOU untuk melaksanakan pelatihan-pelatihan ya, walaupun memang sebetulnya baru sekali ya, mudah-mudahan bisa selanjutnya kita terus bersinergi terus. Nah, ini ada asosiasi yang sudah bekerja sama dengan kita dalam melaksanakan pelatihan-pelatihan ya. Nah, ini salah satu contoh sertifikatnya. Jadi di sertifikat ini ada juga sertifikat yang sudah ditandatangani sama asosiasi yang bersangkutan, seperti itu. Nah, ini adalah salah satu foto MOU pertama kali dengan ITB, itu udah MOU, kemudian dengan Indonesia, Asosiasi Korosi Internasional, kemudian dengan dengan PI juga, dan kalau untuk dengan MOU dengan IAFMI karena keburu pandemi, jadi kita belum sempat foto bersama ya, Mbak Desi.
Ya.
Nah, apa yang dilaksanakan di garin training ini, ada 3 tipe training. Yang pertama itu adalah training yang regular. Regular itu yang tadi seperti tadi ya. Jadi kita biasanya mengadakan training sendiri dengan para expert di bidangnya. 2 hari mungkin di kelas, 1 hari kita ajak ke project atau ke sesuatu hal untuk praktikum di situ. Kemudian ada in-house training. Kemudian yang terakhir ada sponsorship training. Nah, untuk in-house ini sebagai salah satu contohnya adalah dulu kita pernah diminta dari PGN untuk mengadakan training tentang project management. Nah, untuk sponsor training kita pernah diundang sama PT International Paint Indonesia dan juga PT Liber Indonesia Perkasa untuk mengadakan seminar tentang tentang pelatihan yang berhubungan dengan produk mereka. Nah, kemudian untuk media apa yang sudah dilaksanakan, kita udah ada media, ada video ya. Video itu ada video project dokumentasi, kemudian ada internal video documentation, dan ada juga video yang berbasis sponsor. Nah, untuk project documentation ini kita udah sama Kemenhub, tepatnya dari PPK LRT Jabodebek, kita udah meliput 3 video di sana tentang progres project LRT Jabodebek. Ya, semoga juga mungkin bisa bekerja sama IAFMI untuk bikin suatu video yang berhubungan dengan offshore platform, misalkan di pabrikasi, di mana gitu misalkan, kayak di Gunanusa atau di McDermott. Dan if it is possible, maybe we can make the video action file progress, maybe ya, CJ, if it is possible. That's one.
Boleh.
Nah, ini juga kalau project video documentation itu seperti ini. Ini adalah stasiun Matraman yang digadang-gadang akan menjadi sentralnya stasiun di Jakarta. Kalau di Kuala Lumpur mungkin KLCC ya, CJ. Nah, ini kalau video yang berbentuk sponsorship itu biasanya kita mengadakan ilmu. Jadi kayak ini adalah salah satu, semuanya ada di YouTube. Saya di sini di video ini dijelaskan bagaimana sih produk-produk dari jembatan itu gitu. Untuk pengenalan ke mahasiswa khususnya dan juga para pakar di bidang precast, dan di sini kita guide dari Wika Beton sebagai para yang memproduksinya gitu. Kita kenalkan seperti apa, seperti itu. Nah, ini mungkin mimpi ke depan, ya mudah-mudahan aja ya, karena kita pengen jadi kayak Garin Holding suatu saat gitu, semoga ada jalan. Oke. Mungkin ini adalah training selanjutnya. Kita akan mengadakan training tentang MLT RRT System dengan PI Learning Center dan juga dengan IPB. Sebenarnya ini tanggal 12 Juli ya, cuman undur karena ada sesuatu hal, ada yang sakit sebetulnya. Jadi nanti kemungkinan besar dalam 1 atau 2 minggu lagi akan kita laksanakan. Kemudian ini training selanjutnya dengan PI juga tentang Pavement Design Off-Road, Engineering and Construction. Selanjutnya dengan Indonesia kita ada Material Selection, Fundamental and Practice. Kemudian juga dengan Counting, Fundamental and Design. Seperti itu. Ya, mungkin saja yang bisa saya sampaikan ya. Selamat mengikuti webinar kami dengan Action File Teknologi, dan sebagai pembuka mungkin saya sampaikan CV Pak CJ ya. Jadi Mr. CJ ini 40 tahun lebih gitu. Dia berkiprah di oil and gas offshore construction experience. Jadi kita bisa benar-benar mendapatkan ilmu. Jadi jangan sungkan-sungkan untuk ditanyakan apa aja keluh kesah yang berhubungan dengan file section ini. Jadi sekarang stay-nya di Kuala Lumpur ya.
Correct.
Mungkin itu saja yang bisa saya sampaikan. Untuk selanjutnya saya serahkan waktu kepada Mbak Desi untuk membuka dari pihak IAFMI. Silakan Mbak Desi.
Terima kasih Pak Bagja Kurniawan atas opening speech-nya. Bapak Ibu sekalian, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sehat. Semoga kita semua dalam afiat pagi ini. Mewakili IAFMI, saya menyampaikan selamat datang dan terima kasih sudah bergabung dengan kita kali ini yang merupakan kerjasama antara IAFMI dengan Garin Infrastruktur. Saya saya tidak akan berpanjang lebar mengenai apa itu IAFMI, cuma mungkin nanti kalau ingin masuk ke website kami gitu ya, bisa dilihat di sini iafmi.or.id. Pada intinya kami adalah asosiasi ya, jadi asosiasi profesi bagi profesional di bidang fasilitas produksi hulu migas. Jadi kalau Bapak Ibu tahu mungkin kalau di upstream atau hulu migas itu ada beberapa asosiasi lain yang semuanya berbasiskan disiplin keilmuan. Jadi ada yang geologis, ada yang geofisika, yang ahli perminyakan, dan kami di sini mewakili di luar itu semua, yaitu di atas atau surface ya, surface facilities. Jadi disinilah tempat kita bergabung dan karena kami adalah asosiasi profesional, ini adalah visi misi kami mengembangkan jaringan, kompetensi, profesionalisme tenaga ahli. Jadi ini adalah bentuknya. Salah satu bentuknya adalah mengadakan sharing session, webinar seperti ini. Dan terima kasih sekali hari ini Garin, yaitu Pak Bagja sebagai Direktur Utama sudah menyambut baik dan melaksanakan webinar kali ini. Mudah-mudahan bisa terus ke depan, Pak Bagja. Sementara kalau untuk training-training, IAFMI sendiri karena kami adalah asosiasi profesional, kami tidak mengadakan secara langsung, tapi kami juga banyak kerjasama diantaranya dengan PII salah satunya, dan saat ini hari ini sedang berlangsung pelatihan mengenai project controls dan project planning and controls. Jadi silakan kalau mau lihat bisa lewat Garin, bisa lewat PII, itu ada biasanya di sosial media mereka masing-masing, selain juga di sosial media kami. Bapak Ibu sekalian, selain itu juga kami bisa dilihat di sini, kami lebih fokus kepada menjadi partners ya kepada para pemangku kepentingan. Terutama diantaranya adalah pemerintah, dalam hal ini SDM dan juga SKK Migas untuk memberikan masukan kepada mereka terkait kebijakan-kebijakan. Dan kami juga mendorong pengembangan dari industri nasional. Ya, kami juga mendorong karena memang stakeholder kami atau anggota kami bukan hanya para engineers dari KKKS atau dari konsultan gitu ya, tapi juga para kontraktor. Ya, vendor, kontraktor, supplier materials, ya EPC contractors itu juga adalah stakeholder kami dan juga anggota IAFMI. Baik, demikian sambutan dari saya, singkat saja, dan saya mohon maaf nggak bisa stay karena ini ada acara selanjutnya. Terima kasih Pak CJ for taking the time to share with us today. I mean, like CJ is is in fact like my new colleague, but it feels like a long time friend for me. Well, he speaks excellent bahasa ya. Jadi Bapak Ibu nanti silakan digali ilmunya dari beliau ya, dan silakan bertanya. Terima kasih, enjoy the webinar ya, dan mudah-mudahan untuk Bapak Ibu yang juga bergerak di bidang migas gitu, we probably meet some other day. Terima kasih, salam sehat, wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih, Bu Desi.
Ya.
Sama-sama.
Terima kasih Mbak Desi. Ya, semoga kita terus bisa berkolaborasi ya ke depannya. Ya, untuk selanjutnya, karena kita udah jam 9 lebih ya, apa yang ditunggu-tunggu akan segera hadir. Dan untuk selanjutnya, waktu dan tempat saya persilahkan ke Bang Tigor nih Bang, untuk semuanya mengontrol acara sama Mas CJ. Silakan Bang Tigor.
Terima kasih. Terima kasih.
Baik, wait CJ. This my turn. Okay. Terima kasih Pak Bag. Ya, terima kasih Bu Desi atas kesempatan pagi ini. Terima kasih untuk teman-teman yang sudah hadir. Mudah-mudahan pagi ini kita mendapatkan pencerahan tentang suction pile. Sekali lagi saya memperkenalkan diri. Nama saya Tigor Hutabarat. Saya sebagai Kepala Civil Structure di Departemen IAFMI. Kali ini kita akan berbicara tentang suction pile. Jadi sebelum nyampe ke sana, saya kasih refreshing dulu sebentar ya. Jadi saya akan kasih refreshing dulu. Oke, saya kira ya, oke. Jadi saya kira ini sudah bisa dilihat ya. Jadi sebelum kita masuk ke section file, saya akan coba merefresh teman-teman semua. Jadi untuk instalasi file di offshore khususnya, sebetulnya itu ada 4 cara ya. Sebelum nanti kita bertanya sebetulnya suction file itu apa, baiknya kita merefresh kembali. Sebetulnya metode peninstalan di offshore khususnya ada 4 cara. Yang pertama itu adalah file driving. File driving ini sudah common, kita menggunakan hammer ya, dan juga ini di darat juga terjadi sama metodenya, cuman kalau di laut kita menggunakan kapal dan hammernya diangkat pakai crane ya. Ini sangat umum dipakai. Jadi semua untuk fasilitas fixed platform yang semua berbau fix diinstal pakai file driving ya. Oke, jadi ini yang common dilakukan ya. Baru yang kedua bore pile. Nah, bore pile juga common di darat ya, untuk membuat fondasinya yang dalam untuk bangunan yang sangat tinggi. Kadang kalau tidak mengizinkan untuk dipancang karena goyangan di sebelahnya, maka akan dilakukan pengeboran. Jadi pengeboran ini sama menggunakan alat bor dulu ya. Jadi mengeluarkan tanahnya, sesudah itu masukin pile-nya, baru kalau memang beton ya memang pada umumnya jadinya beton ya. Jadi kalau di laut pun sama. Ini dibor dulu, jadi kalaupun baja yang dimasukin tetap akan di-grouting di sekitarnya. Jadi ada unsur konkretnya juga ya. Itu bedanya kalau misalnya boring di laut dengan menggunakan pile baja ya. Jadi setelah pile bajanya dimasukin dilakukan juga pengecoran. Itu metode yang kedua. Ini biasanya dilakukan untuk konduktor ya. Kalau konduktor biasa dilakukan dengan bor karena mereka akan melanjutkan untuk pengeboran sumurnya ya. Jadi untuk praktisnya mereka melakukan dengan boring, bukan dengan pancang. Tetapi bisa juga dengan pancang kalau memang konduktor dipasang oleh EPCIC kontraktor, sama halnya dengan memasang pile. Nah, yang ketiga, walaupun ini jarang kita dengar, tetapi teknik ini ada dan ini saya pernah melakukan untuk subsea konduktor di sel Sarawak Malaysia sana, namanya jetting konduktor. Nah, bagaimana jetting itu prinsipnya adalah ini pile-nya ya, kemudian dari pile ini dipasang pipa kecil ya, pipa kecil, terus di ujungnya dikasih nozzle. Kita lihat di sini ya, nozzle ini. Oke. Prinsipnya gimana? Ini turun, kemudian ini mompa, ini harusnya jet ya. Ini jet, kita lihat ini kelihatannya jet. Jadi dia di jetting airnya sehingga sehingga tanahnya keluar, pile-nya masuk. Oke. Sehingga dia turun. Jadi seiring dengan jetting dia akan turun. Oke, dia akan turun. Nah, konsekuensinya tanahnya ini yang akan terganggu kan ya. Jadi concern di sini adalah masalah settlementnya tanah. Untuk konsolidasi dia butuh waktu, tidak segera untuk dapat konsolidasi seperti yang kita lakukan pada saat driving ataupun pada saat boring. Ya, jadi di sini ada waktu yang ditunggu dulu supaya pile setelah masuk pile itu ngegrip kembali, mengikat kembali ikatan antara tanahnya sehingga dia punya kekuatan yang kita harapkan. Oke, baru yang terakhir suction pile. Ya, suction pile saya hanya pengantar, nanti akan disampaikan Pak CJ. Oke, baik. Untuk suction pile saya akan coba kasih sedikit peragah. IT mohon saya dibuat untuk spot dulu. IT minta tolong saya dibuat spot dulu. Ya, oke, thank you. Baik. Bapak-bapak mungkin sudah bisa.
Suaranya, Bang?
You lost your audio.
Bang Tigor.
Oh, oke.
Yeah.
Ya, sip.
Oke, now, oke. Jadi bapak-bapak semua udah bisa lihat di sini?
Iya.
Oke. Secara prinsip saya mau sampaikan, menyampaikan prinsip basic saja sekarang di sini. Suction pile itu bekerja kalau ada air, ya. Di sini kita berbicara air. Ini ada air di dalam botol ini. Oke. Kalau nggak ada air kita nggak bisa kerjakan suction pile, ya. Prinsip dulu ya. Yang kedua, saya tunjukkan di sini sekarang kelihatan ya, ada dua nih ya. Satu, saya turunin dulu ini. Ini kira-kira seperti suction pile, walaupun bukan suction pile, ini tiruannya saja ya. Ini jelas ya, kelihatannya. Nah, yang mau saya lihat adalah di dalam sini kan ada udara ya. Di dalamnya ini ada udara. Oke. Jadi, udara ini nanti yang akan kita manfaatkan untuk memasukkan suction pile. Jadi, secara prinsip, suction pile ini hanya menggunakan alam ya, alam dalam arti udara dan air ya. Jadi bagaimana kita memanage udara dan air ini, perilakunya di dalam medium ya, hukumnya yang berlaku tentunya hukum Archimedes ya. Kemudian dengan tekanan pakai asas Bernoulli. Dua hukum ini kita pakai untuk menyelesaikan fenomena suction pile. Apa artinya suction? Suction sebetulnya sedot, isap gitu ya. Jadi nanti ketika kita masukin ini ke air, kalau udaranya ini nggak keluar, airnya kan akan naik. Ya. Nah, fenomena suction pile, udaranya yang kita isap sehingga ini menekan. Seberapa tekanannya adalah seberapa tekanan air yang dipindahkan. Oke. Yang besarnya sebesar tekanan rho GH. Oke. Nah, sekarang saya tunjukkan ya. Baik, coba dilihat. Ini kalau kelihatan mungkin di layar bahwa level air ini adalah di level yang hijau sekarang, ya. Nah, sekarang kita lihat. Saya masukkan ini suction pile-nya, ya. Saya masukin ke dalam. Nah, sekarang karena dia ada udara di sini, saya akan tekan. Kalau nggak saya tekan, nggak akan bisa masuk. Nah, ketika saya tekan, airnya sudah naik ya ke level yang merah, ya. Kelihatannya udah di level yang merah sekarang ya. Oke. Jadi tekanan yang harus dibutuhkan untuk memasukkan suction pile ini adalah sebesar H ini, perbedaan ketinggian tadi. Berapa besarnya? Ya, rho GH, sesimpel itu. Ya, rho GH. Rho kalau air 1000, kalau G misalnya 10 dan H 10 meter, misalnya di kedalaman 10 meter dengan luas 1 meter, kita punya tekanan sebesar 100 ton. Ya, 100 ton ya. Sehingga kalau suction pile pada umumnya ini luasan ini jadinya besar ya, supaya kita mendapat luas tekanan yang besar ya. Jadi sekarang kebayang kalau dia di kedalaman 10 meter kira-kira akan ada 100 ton. 20 meter 200 ton. 30 meter 300 ton dan selanjutnya. Nah, pertanyaan berarti sekarang di kita semua yang mungkin nanti akan ditanyakan, silahkan akan ditanyakan, berapa kedalaman minimum supaya kita menginstall suction pile ya. Terus berapa kedalaman maksimum yang bisa dicapai suction pile ini, ya, karena kita hanya menggunakan ROGH, ya, ROGH yang kita punya, sehingga ada keterbatasan. Juga ada keterbatasan dari segi tanahnya. Apakah dengan force alami ini, ROGH ini, kita bisa mengatasi, katakan kalau batuan keras atau ada kerikil gitu ya. Jadi tidak semua tanah bisa dipasang untuk suction pile. Nah, untuk detailnya nanti akan disampaikan Pak Siji. Jawabannya yang saya sampaikan ini hanya prinsip dasar aja. Nah, kalau sekarang ditanya, silahkan jawab, kata Pak Tigor bahwa suction pile itu adalah ROGH gitu ya. ROGH kuncinya. Kalau kita nggak punya H-nya, nggak punya RO-nya, kita nggak bisa install ya. Jadi kedalaman air itu sangat menentukan. Saya kira itu pengantar dari saya. Nanti pertanyaan-pertanyaan yang muncul dari Bapak Ibu mungkin sudah ada. Silahkan disimpan, kemudian boleh di chat nanti ya. Juga bisa nanti bertanya kalau diizinkan untuk bisa pakai voice. Saya kira itu aja pengantar dari saya. CJ, I already briefed the audience with the suction pile technology. So I think the screen now is yours. Let us welcome Mr. CJ. Thank you.
Well, thank you, Pak Tigor, Pak Bagja, and Bu Desi. Yeah, much appreciated. Is the audio clear?
Yeah.
Okay. Thank you, first of all, to Garin and IAFMI for allowing SPT this opportunity to share the technology today in Indonesia. And of course, thank you to all the participants for joining us on a Saturday morning. So I hope we can make it worthwhile your time and interest. We have about a 1-hour presentation with a 5-minute video included in the end. Now, I have been asked by Pak Tigor for you to pay close attention to the presentation, because at the end of today's session, Pak Tigor will have a quiz, yeah, with 5 questions and 5 token gifts, and the answers to the quiz are all embedded in the presentation. So hopefully you will pick it up. It's an opportune time to share suction pile technology today with the audience, because SPT and Pertamina are actually currently in discussion to deploy this technology in Indonesia on one of their field developments, upcoming field developments, where driven piles may not be suitable because of shallow gas pockets. So Pertamina, I believe they are participating today in the presentation. They are looking at potentially deploying suction pile technology. So that will be a first in Indonesia. So it's a good timing today. I've been doing a lot of presentations over the past 1 year for companies in Indonesia. So some of you will probably recognize some of the slides today, hopefully. Yeah, consider it a refresher course. And Pak Baya, you know, you worked in Singapore, Abu Dhabi, Papendrecht.
Yeah.
Yeah, same for me. I worked in all 3 places, and seeing Stavanger and Oslo also bring back good memories, because I also worked in both Stavanger and Oslo.
Okay, nice.
So a lot of how to say, walking down memory lane today.
Yeah.
Yeah. So my background, 40 years in offshore construction, mostly T&I and EPCIC. So my primary interest in the technology is the offshore installation phase, because that's my background, and that's where the technology is really cost effective. So yeah, my background, I've executed projects, offshore projects across all the continents, all the 5 continents in my working life. Yeah. And I really hope that this technology will be recognized for its value, and that we can soon have a broader exposure for this technology in Indonesia. Yeah. So without further ado, I've been given 1 hour, so we're a bit behind schedule, so we try to catch up. Yeah. Okay, I'll switch off my video to share screen. Okay. Hold on. Okay, can we all see? Have I lost you?
Yeah, it's good. It's good. So
yeah, okay. Yeah, clear.
Yes,
clear.
clear.
Okay.
Clear. That's good.
Bagus. Okay, so let's. Okay, again, yeah, this today is all about suction piles. We have about 50, 60 slides, so some slides will can go through fast. There's mostly visual impressions. Some slides we will elaborate a bit more. So yeah, this opening slide, a quick introduction. Here we can see a suction pile jacket on the bottom right-hand side. After explanation from Tigor, this is the real thing. Yeah. As you can see, suction piles are pre-installed in the fabrication yard. Yeah, whereas the driven pile, the conventional driven pile solutions, they are installed offshore. Yeah, so but suction piles are pre-installed in the installation yard, thereby reducing a lot of offshore activity. The second element in the opening slide is you can see that the installation vessel here is a fixed shear leg. Suction pile technology is suitable for fixed A-frame shear leg installation, or can also, of course, be installed by the conventional typical revolving crane on with derrick barge. Yeah, so. But because there is no pile handling, no pile stabbing, no welding and all that, the shear leg is actually quite suitable alternative for installation purposes. The third element in this slide is what you see here is, as you can see the wording on the top right. Yeah, actually here you see a platform relocation in progress. Yeah, that is one of the key elements for suction pile technology, that it can serve as a fixed platform, a fixed foundation. Yeah, but it always allows the customer to relocate the structure in the future, because this pile installation can be reversed. Yeah, so that we'll have a video on that in the end on one of our relocation progress, so we will see a bit more details later on. Today, the presentation will talk a little bit about design aspects, SPT, a short introduction of SPT offshore capabilities, the technology and the suction pump spread. There will be we will show two example projects, one in wind, one in oil and gas. And of course, we will try to highlight as much as we can the suction pile benefits from a client perspective. And then at the end, we have some Q&A session for half an hour at the end of the presentation. Okay, SPT stands for Suction Pile Technology. We were founded in 1997 in Holland. It's a Dutch company. It's a small Dutch company. We have about 50 or 60 permanent staff. Of course, quite a lot of freelance or flexible staff, but the core is about 50, 60 people, mostly engineering, geotechnical, and structural. SPT has developed from an engineering, from detailed design in structure pile engineering, we have developed into a EPCI contractor over the years since 1997, with specialized in suction pile foundations and suction pile moorings. We have designed and installed over 600 suction piles worldwide today. Yeah, so it is an extensive track record and proven technology. Suction pile technology and SPT are active, very much active in oil and gas, offshore oil and gas, and offshore renewables. So suction piles are only suitable for offshore applications. They're not suitable for onshore application. Inshore, perhaps, but not onshore. But suction pile technology is becoming very popular in these days in wind and offshore wind and renewable projects. Suction pile solutions allow for innovative tailor-made solutions, even brownfield. It's not only greenfield technology, it is very much suitable for brownfield solutions as well. So greenfield, brownfield, installation and relocation solutions are available with suction pile technology. And suction pile technology is suitable for both shallow and deep water. Capabilities. Yeah, we do, of course, we are by nature, we started off an engineering company, so we do concept, pre-feed and feed studies, detailed design for suction piles predominantly, but we have also some interesting substructure designs that we could offer to our clients, lightweight structure designs, early production systems, self-installable substructures. Of course, we do fabrication for suitable projects. We provide support services to the offshore installation contractor, calling suction pump and so manpower and equipment during installation. Our ambition is to grow as a T&I contractor in not only in Asia Pacific but also globally. So in the last 10 years, SPT has developed more towards the T&I segment, and hence my role today with SPT. And we of course take on full EPCIC projects of a suitable size. Applications for suction piles can be, of course, applied to that's our key market, suction pile jackets, substructures, both wind and oil and gas. As I said, we provide self-installing platform solutions where we can eliminate the need of an installation crane vessel, a heavy lift vessel. They are used for subsea templates, subsea manifolds, riser foundations, even for deep water span corrections. We use suction pile solutions. There are suction pile technologies used for mooring piles and anchors, and we provide pipeline startup services to the big pipeline contractors like Allseas and Saipem. When required. The typical slide, this is our global track record, customer track record. So we've been in business 25 years with a lot of happy customers, or satisfied customers. Happy is probably some happy, some satisfied, but all very very pleased with the outcome of their projects. SPT, as I said, small company, based in Holland. Right halfway between, for those familiar with Holland, between The Hague and Utrecht along the highway in Woerden. So here we have a quick impression of our global project footprint. Of course, being based in Holland, we have done quite a few projects on the North Sea, both oil and gas and wind. But you can also see going west, Gulf of Mexico, deep water moorings. Then we turn east to the west coast of Africa. But more importantly, in the Southeast Asia, you can see a number of blue dots where we have executed projects. To date, we have successfully in Malaysia executed 6 suction pile projects for various clients. So Indonesia, not yet. So we really hope that that we can come to an agreement with Pertamina to introduce this technology into the Indonesian oil and gas market. Okay, a picture says 1,000 words, as they say. Well, this is what suction piles look like. Top left is the same as in the introduction slide, the first slide. Again, suction piles compared to the conventional driven pile solution. The driven piles are long and slim, often 80 to 100 meters long, and they need to be welded offshore in sections. Suction piles are short and fat, so to speak. They have a larger diameter, but they have a much shorter length. Yeah, a typical diameter for the suction pile is about 6 to 9 meters. Yeah, and depending on soil conditions, be it sandy, be it clay, the length is typically 1 to 2 times the diameter. Yeah, so if you have a 6 meter diameter suction pile, then typically the length is somewhere between 6 and 12 meters. Yeah, of course, if you have very liquid soils, then they may be a bit longer, but this is what they look like. Yeah, they, as you can see, the paint markings on the suction can, so to speak, on the suction pile, because the penetration into the seabed is a controlled process, and of course there is a target penetration based on engineering analysis. Yeah, so hence the paint markings. On the right we see bottom right we see what we call a monopile based on suction pile. This was a brownfield project in Malaysia. One of our clients wanted to do a deck extension for one of their platforms, but there was no space on the existing platform, so they decided to extend the top deck, but they didn't want to have a driven pile solution because it was a live platform. So they engaged SPT to design, develop two legs, support legs actually, for the deck extension based on suction pile technology, and this is one of them being lifted from the quayside into the water, and then it was a wet tow to location. A bit more impressions. Here we can see a four-leg jacket sitting in the yard, about to go offshore. There you can see roughly the ratio, the size impression compared to a four-leg jacket. In the middle on the top, this is a mooring pile. You can see there the mooring chain. Interesting to see that the suction pump is on top of the pile. These are also pre-installed in the yard, as we will see later. Bottom right is a tripod jacket with suction piles, and on the bottom left, a tripod with suction piles being towed to offshore location. And on the right, we see this is an SPT proprietary design called SIP1, which is basically a minimum facility with a monopod with 3 suction cans. As I mentioned earlier, the suction pile technology is also deployed for subsea manifolds. As you can see here, a variety of subsea manifolds for mooring piles, top right. And bottom right, we see what we call a cluster pile. And a cluster pile is 3 suction piles welded together. And that is done when project requirements dictate optimum verticality. Yeah, a standalone mooring pile, suction pile can achieve verticality probably plus within 5 degrees, but a cluster pile can achieve verticality within 0.5 degrees, half a degree. So that's the idea of a cluster pile. Okay, how do they work? As I said, Tigor has already tried to explain, if my Bahasa doesn't let me down entirely, the principle of the suction pile, but this in a bit more schematic manner. Suction piles, as I said, are pre-installed in the yard. So upon arrival at offshore location on the transportation barge, we can either depending on the water depth, we can transport the jacket either in a vertical position, or if it's a larger water depth, we do it in horizontal position. After upending offshore, we lower the jacket into the water, to the seabed. And of course, upon reaching the seabed, the piles will self-penetrate straight away. Yeah. So during this phase of self-penetration, which is a control process, again, it's pre-calculated by our design engineers, how based on the soil conditions, how far we will self-penetrate. But during the self-penetration, you can see in the schematic, the valve on top of the suction pile is left open. So at this point in time, there is no differential pressure between inside and outside of the pile. The hydro pressure is the same inside and outside. Yeah. The foundation principle is very much similar to a driven pile. Yeah. Tip resistance, shell friction. Driven piles are longer and slimmer. Suction piles are larger from diameter perspective and shorter. So, but we have an added feature whereby we have, because we have a larger diameter, we very much depend on what we call top plate bearing water pressure. Yeah, and we see that in the next slide. Now, the suction pumps, which you will not see here, but you will see that in the next slide. Just like the suction pile is pre-installed in the fabrication yard, the suction pump skid is also pre-installed in the installation yard on top of the pile. This is all done to minimize expensive offshore activities. Yeah, offshore activities with heavy lift vessels are typically expensive and they carry risk. So whatever you can do in the yard, you do in the yard. Then from the suction pump skid, as we can see in the next slide, yeah, schematic. Here we see the suction pump skid sitting on top of the pile. Yeah, from the suction pump skid, you can see an umbilical running to the surface. The umbilical is also pre-installed in the yard and tied to the jacket legs and to the top of the jacket. So upon the completion of self-penetration, the umbilicals, whether it's a tripod structure or a four-legged structure, each pile will have their own suction pump. Yeah, so if you have three-leg tripod jacket or a four-leg jacket, there will be 3 or 4 suction pumps pre-installed. The umbilicals will be retrieved from the jacket onto the installation vessel, where we have our control cabin pre-installed, and then the suction pump or the umbilicals will be connected to the control cabin, and from there the suction pump operations will commence. Now, self-penetration completed, umbilicals recovered and connected to the control cabin on board the installation vessel. We now activate the pumps, and effectively we start creating a under pressure in the pile. Yeah, we pump out the water and liquid soils from the pile. The pressure outside, of course, is the same, but we create an under pressure in the pile. Thereby, we are effectively driving the pile further into the seabed until target penetration, as you can see. Typically, upon reaching target penetration, there's about 2-3 feet of suction pile or suction can left above the seabed. The suction pumps are equipped with an inclination sensor, as you can see on the bottom right. And the leveling process of a suction pile jacket is a relatively easy process because we can control each suction pile individually. So if one leg has to go down a bit further or 2 legs to achieve jacket level within tolerance, then that can be relatively easily achieved as compared to a driven pile solution, where the leveling process typically is quite a brute process with jacks and the leveling system. Here the schematic on the umbilicals. You can see, yeah, the umbilicals from the pumps outside the dotted square. The umbilicals run to the vessel onto an umbilical wheel, and from there they go through the control cabin. It's I can't make it any simpler. This is it's a fairly simple process. SPT design, build, and own their own fleet of pumps. Yeah, currently we have about 20 pumps operational worldwide. We have deep water pumps, shallow water pumps. We have slow pumps, fast pumps. Yeah, so again, horses for courses. Certain projects require certain pumps, and of course, after 25 years of experience, we typically have the right pump for the right project. Top right, we see the control cabin, impression of the control cabin. Yeah, and the control cabin is of course installed onto the offshore installation vessel during mobilization in port. Okay, we talked about the suction pumps being pre-installed in the yard. Here a quick impression. Here you can see it. Yeah, the yellow structures on top of the suction piles. Yeah, the suction pumps. So you can see here that each suction pile has its own suction pump skid, pre-installed in the yard. In terms of design space, here you can see from this slide that a larger and a very narrow, you can see the scale on the bottom axis is the suction pile diameter, the left axis is suction pile length. So below a certain diameter, suction piles are not effective, and above a certain length, suction piles are not no longer how to say competitive. So we typically where are the typical the suction pile design space is a relatively is a larger diameter, as I told you, 5-6 meters onwards, and a length of 6 to 10 meters. So this is where our design space typically where we find suction piles to be technically and cost effective. In terms of soils, of course, we get a lot of questions. Soils, when are suction piles suitable, when not suitable? On the left, a summary of four bullets. When suction piles are not really suitable, when we have water depth less than 10 meters, then it typically becomes difficult for us to come up with a solution. Above 10 meter water depth, we can typically come up with a solution. When we encounter or when the soil data shows hard rock, hard ground, rock hard clay or bedrock, then suction piles are typically not suitable. You find hard soils, rock hard clay, typically in the Middle East, and sometimes in Australia you find bedrock, and then typically you would require a drilled pile solution as presented by Tigor earlier. If there's no sediment, yeah, and especially on when there's a steep sloping seabed, it will be difficult to deploy suction piles. So from there, yeah, we progress to conditional suitability, to feasibility, and to very suitable circumstances, which is deeper water, not necessarily deep, but deeper water. Clay and sandy soils. There's often we get the question: can suction piles be deployed in sandy soil conditions? The answer is yes, very suitable, and any combination of sand and clay, layered soils, is suitable for pile conditions. So the first thing we always ask when a client approaches us for a suction pile, a potential suction pile solution is representative soil data. From there we can, within 1 or 2 days, we can tell whether suction piles are suitable or not. So It's a very, very tried and tested process by our geotechnical engineers. The suction pile solutions, here a bit of a cartoon impression of the various applications. As I said, of course, suction pile jacket solutions, yeah. Be it tripod, be it a four-legged, even 6 or 8-legged jacket substructures can be supported by suction piles. We can launch suction pile solutions, yeah, jacket with suction pile solutions. So that's been done. It's been tried and tested in our track record. And suction piles, from a design perspective, are suitable up to we can come up with solutions into a maximum of 120 meters water depth. Yeah. To date, our track record for substructure suction pile installation is 104 meters to date, but we can go up to 120. I mentioned pipe lay startup. We support the big pipe lay contractors like Saipem, Allseas, and the likes up to 300 meters, 3,000 meters of water depth for startup piles. We provide mooring solutions, suction pile mooring solutions, and suction pile anchors, as you can see here. We talked about subsea structures, manifold, plan-plat, as you can see here. We go. Most of these solutions are suitable for 3,000 meters of water depth, and we have a track record into that range. Definitely beyond 2,000 meters. I don't know whether we have gone to 3,000. With the Gulf of Mexico, we may have done that. But out of these 4 jackets, obviously have a limitation of 120 meters. Now, we talked about wind in the early slides, that suction pile solutions have become very popular for offshore wind farm development. Currently, SPT has done the detailed design and is now doing the installation for 76 wind farm foundations in China. Yeah, 76. We recently did a wind farm development in Europe, in Aberdeen. 11 substructures, which we will talk about a bit later. But these are significant jacket substructures. Yeah, they go up to 1,500 ton. I mean, the turbine capacity has increased tremendously. And nowadays, you must imagine a turbine with a wingspan of about 150 meters. Yeah. So these turbines, they require almost near perfect verticality, and you can imagine the forces that will enter into the substructure and into the suction pile foundation. So, but it's a very efficient, a very how to say capable foundation solution for wind farm. Then you see SIP2. SPT is the owner of some proprietary technology of some self-installing platforms. This is one of them. This is a 4-legged self-installing platform design 2, type 2. The limitation here to date is the water depth. It's only suitable up to 60 meters because, as you can see, there is no cross bracings between the legs. Yeah, so beyond over 60 meters, it becomes somewhat unstable. Although the engineers currently are working on solutions for deeper water, but the SIP2 does not require a heavy lift vessel for installation. And this design can have topside weight of up to 15,000 tons. So this can also be used for a CPP, central processing platform solution. Here a quick snapshot of substructure weights across the water depth. These substructure weights are suitable for topsides around 500-600 tons. So you can see the substructure for 35 meters is 200 tons, for 60 meters is 400, and for 85 is about 600. That is excluding the suction pile weight, yeah, including the suction pile weight is based on the tripod. The total steel weight for substructure, including boat landing and suction piles, etc. For 35 meters, you're talking about 440 tons. For 60 meters, you're talking about 720 tons. And for 86 meters, 85 meters, you're talking about 975 tons. Just to give you an impression of where we keep optimizing our substructure designs to make it as cost effective for our clients as possible. Here we show a split jacket concept because we have recognized over the years that in certain areas where we execute projects, you don't always have big crane capacity available. Sometimes a smaller crane vessel with smaller lift capacity, with smaller lift height capacity, may lead the client to consider a split jacket solution, whereby you can see the suction pile template is pre-installed, and the substructure is subsequently stepped onto the suction pile template. Now, this is a common concept in wind farm developments. Yeah, not so much yet in oil and gas, although it's coming. We're looking at quite a few solutions at the moment. The split jacket, the jacket split does not have to be at seabed level. We can introduce the jacket split also at a higher level. So that's just a matter of engineering. But that is possible to create a bigger playing field, a wider playing field for the offshore installation contractors, and to give the client more options to choose from an installation perspective. We spoke about oil and gas, wind farm, and we talk about, this is just a summary, a few bullets. We'll see if the details of this a bit later, but suction piles are typically associated with fast installation. It will take about 1 to 6 hours per pile to reach target penetration. No leveling tools required. As I said, leveling is a relatively easy process. No grouting required for suction pile solutions. No mud mats required. No seabed leveling required because the 3 piles individually go straight into the seabed. And there's no mud mat, so typically with a conventional structure, driven pile structure, you typically have mud mat, so you need a level seabed. Also, suction piles remove the risk of on-bottom stability because they penetrate straight into the seabed. Earlier we talked about suitable soils a few slides back, and I mentioned bedrock is of course not suitable for suction piles, but if the bedrock starts 8 meters or further down below seabed, 8 meters or more below seabed, we can typically come up with a solution. Same goes for wind turbine foundations. Yeah, same bullets. And we also do we install floating wind anchors and FPSO moorings. As I mentioned, we have the option of installing single mooring piles, and of course cluster piles for verticality precision, as I said. Yeah, using suction piles for your moorings allow you to narrow down your pattern. The installation is more accurate, and the installation is the location is permanent, unlike drag anchors. Thereby, you can reduce your mooring chain length considerably and potentially save cost. Okay, we spoke in the opening slide about what are the real benefits of use of suction piles. The following slides will share that with you. Suction piles, again, pre-installed in the yard, as you can see on the middle, on the left picture. On the right, we see a loadout taking place of a conventional pile driving jacket, whereby you see many pile sections that have to be loaded on board to be driven offshore in stages. There's no such thing with suction piles. They are pre-installed in a single leg, single piece. So no pile driving offshore, no mud mats required, as you can see here, and no seabed leveling, as we shared earlier. Suction pile technology, suction pile installation is noiseless, so that in certain environmental sensitive areas, fishing areas or ecological areas, the authorities may require noise mitigation. I've dealt with it a couple of times in my working life. On the right, we see a project with noise mitigation. You see the white sea surface circles. Yeah, that is a result of noise mitigation. For suction pile technology, there's no noise, no shock waves, no vibrations. Ultra short installation time, and of course, as I said, we can reverse the process and remove without a trace. Suction piles do not require any pile sleeves, and there are no grout connections. Earlier, I spoke about a split jacket solution, and I forgot to mention that in a split jacket solution, the default connection is a grout connection. In that case, we need to use grout for a split jacket solution. But if the jacket suction pile jacket is installed in one piece, there's no grouting requirement. Yeah, and no pile sleeve for skirt pile solutions required. As I mentioned, easy leveling. Each pile can be controlled individually in small steps. It's quite an accurate process. Yeah, and we mentioned earlier, suction piles have unbeaten verticality control. Yes, fast or maybe fasted jacket installation. We can typically install a suction pile jacket together with the boat landing and topside. I'm not including the conductor installation at this point in time. So just the substructure, boat landing and topside, we can typically do it within 3 days. Anywhere between 3, maybe 4 days, we can install an entire platform ready for conductor installation. So yeah, you can see it's a one-piece installation. Jacket and piles all go into the water in one go, and it's a single offshore campaign. Here we see an impression of foundation depth. Yeah, these are relatively shallow foundations compared to driven piles. Yeah, as we said, the suction piles are much shorter. And in the case of our discussions with Pertamina on one of their field developments, where they encounter shallow gas pockets, the suction pile solutions are an ideal and safe solution to get the correct foundation, the required foundation for the substructures. As I said, there is no mud mat, so for a conventional jacket, after you set the jacket on the seabed, it will rest on the mud mat, so you need a level seabed. And for a moment, the jacket will be unattended because the crane will have to release the slings, and then before this step the first pile. So until the first pile for pile-driven solutions has penetrated the seabed, the jacket is freestanding and sometimes unstable. And if you're familiar with the offshore construction installation industry, over the years, a number of structures have simply toppled over because of poor geotechnical design, yeah, and instability. But with suction piles, there's no such risk of on-bottom stability. The piles go straight into the seabed and the jacket is secured. Just a quick mention, SPT also has a scour protection system in areas where we do consider scour in our detailed design. Yeah, that is part of our package. But a scour solution, we have, I mean, this is our proprietary scour design solution. So you can see here, they are also pre-installed in the fabrication yard. They unfold, they self-deploy during the suction pile installation. There's no requirement for rock dump layers. They are pre-installed in the yard onto the suction piles, and you have immediate scour protection. And the cost savings are indicated at about 50% compared to a rock scour protection. Yeah, we talked about earlier about the uniqueness of suction piles is the fact that the structures can be relocated. It is reversible technology, so the relocation recovery is the same process as installation, only now you create by recovery you create an overpressure, so you reinstall the suction piles because the suction piles are removed after installation. We recover them, so in case there is a relocation requirement, we reinstall the pumps, we reverse the process, and we create an overpressure in the pile, and the pile will push itself, the whole platform will push itself out of the seabed. Yeah. Even if you don't have plans to relocate, suction piles are extremely suitable for a fixed permanent solution. The design life of suction piles is identical to driven piles. They are designed to the same design code, so there's no real difference, and they're equally reliable and durable. Yeah, same design life. And of course, at the end of a design life, at the end of the lifespan of a jacket, of a platform, when decommissioning becomes a point of discussion, suction pile structures can be relatively easily decommissioned. Yeah, and everything is removed when you decommission a suction pile platform, so nothing is left behind in the seabed. Driven pile solutions are typically cut 10-20 feet below the seabed, and the rest of the pile stays in the seabed, but suction piles are completely recovered and nothing is left behind, so environmentally friendly. Yeah, of course, suction pile solutions are designed to bring savings to the end client, and the savings, of course, need to be compared to the conventional driven pile solutions. Yeah, when you do consider suction piles for your foundation solution, yeah, you will realize that there's a number of steel savings, fabrication savings, because, as I said earlier, no pile sleeve, no pile catches, no centralizers, no mud mats, and no leveling paradise or trunnions. There's no overlength of driven pile. Typically, when you install driven piles, you always have to provide some green length, over length, but there's with suction pile there is zero wastage. So these are the fabrication savings. In terms of offshore installation savings, it is a fast process. It's typically around 3.5 days, compared to a conventional jacket, which will take up 7 to 10 days with a driven pile solution, depending on how many piles, how many pile sections, how many add-ons, how much welding to be done. Because it is a shorter offshore duration, it becomes less weather sensitive. So you need a smaller window, weather window to install the jacket or the platform. as I said, a lot of activities take place in the yard, so you reduce the offshore handling activities. Therefore, it becomes a safer and less risky operation. Suction pile jackets do not require any hammer spread, so no prime hammers, no backup hammers, no breakdown of hammers. Yeah, so because there's no pile driving. There is no bear cage, no pile gripper or upending frame required, no noise mitigations, no leveling spread. As I said, no topside interface cutting, green length, and no grout spread. Effectively, you save multiple days of offshore installation spread, which could cost you up to $250,000 a day, depending on the crane capacity. It's also a very suction pile benefits. Suction pile solutions also a very cost-effective solution for the development of multiple marginal fields because they can be recovered and redeployed. Yeah, to relocate and reinstall a jacket, you save about 50% compared to a new build. Yeah. So instead of building two platforms for two marginal fields, if you were to use a suction pile design and relocate the jacket at some point in time and reuse it, you have the high level cost indication is indicate a 50% savings on that process. Of course, when you relocate, when you plan to relocate, you need to take in two key parameters into account. One is soil data, comparable soil data. So you design for the worst soil data of the two locations, and of course water depth. You cannot relocate a 30 meter jacket into 60 meters of water depth. So you need to consider that beforehand. Yeah, this is a bit of a wordy slide, but we did recently, last year we did a study for one of our clients on a 4-legged jacket. This was only at 45 meters of water depth, as you can see on note 1 here. Note 1, 4-legged jacket. We assumed a fabrication cost of about $4,000 per ton, a topside weight of 600 ton. Yeah, and you can see for a new build jacket, we save about 2.2 million in fabrication cost and about 1.4 million in installation cost. That would give you the client, the end client, a saving of about 3.6 million. On the relocation side, a similar process, you save about 6 million in and if you were to consider a relocation versus a new build, then it's about the same, 6.3 million. So altogether, you in the event you consider a relocation in the future, your savings could be to the extent of about $10 million. But this is for 45 meters, 4-legged jacket. So in deeper waters, of course, the savings could be. And depending on your fabrication cost, we've taken 4,000, but if it's 5,000, of course, you save more. It's not all technical, of course. QHSE being a very important segment, element of our offshore oil and gas business. So in terms of quality, it is a proven concept. It's equal or better than conventional solutions. It has the same design life as a driven power solution, and it's, as I mentioned, same design codes. It is a safer concept simply because it reduces the offshore installation activities, it reduces the offshore installation time, and therefore it becomes a less risky operation. And as I said, it's also safer with regards to on-bottom stability because suction pile structures have no risk of on-bottom stability, direct pile penetration. The environment, there's no seabed preparation required, so a minimum disturbance to the environment, no underwater noise, so no noise pollution to the environment. We save steel weights, so resources are protected. Platform is reusable, relocatable, again, resources carbon footprint, and it's easy to relocate or decommission. Nothing is left behind. And nowadays, the discussion definitely in the Western Hemisphere is all about climate-friendly solutions. So by reusing a platform, by cutting down on installation time offshore, you contribute to the end client contributes to a reduced carbon footprint. Some impressions. Here we can see a four-legged jacket. As I said, you can transport it vertically or horizontally. So the top row, left, middle, right, is pre-installation, and bottom is post-installation. Yeah. So this is these are all wind farm impressions. This is a wind farm substation on the left. This is in the middle. It's a turbine foundation, and on the right, it's a floating wind anchor. Okay, now we have come to the section where we discuss two example projects, just to give you a flavor. We recently, SPT recently in 2019, I think it was, we installed a wind farm in the northern part of the UK sector, near Aberdeen. It's called the Aberdeen Wind Farm. At that time, I was the managing director for Boskalis Global TNI, and SPT actually was my client at the time. So I was very instrumental and involved in the installation of this particular wind farm, because these were heavy substructures. As you can see at the bottom, the total jacket weight. Well, the range was between the 11 foundations. It was between 13 and 1800 tons. So these are significant substructure. Turbine foundations. Yeah. Water depth was relatively shallow water, 19 to 32. And the total installation program, design and installation was 11 suction pile structures. Here we can see the process. On top we see the concept design company, the detail design company, the suction installation contractor, Boskalis, as I mentioned. But at the bottom you see SPT's involvement across the entire value chain. Yeah, input into the concept design, input into detail design, and offshore installation support. And this is what they look like. Transport of jackets, again, vertical transport. Because of the weather sensitivity in UK waters, the jackets were actually lifted off the cargo barge, as you can see here, in an onshore location. And the shear leg, as well, we deployed actually 2 installation vessels because we had a short weather window that year. So we decided to go with 2 installation vessels. One was a shear leg, as you can see here, and the next and the previous one, as you see, no, that will follow, is a conventional revolving derrick barge crane. Yeah, that was a Harima vessel actually. So the liftoff was inshore. Here you can see the second installation vessel, which was a Harima installation vessel with a revolving derrick, revolving crane. So they loaded the jacket, they lifted the jacket inshore, sorry, from the installation, from the transport barge, and then with the load in the hook, both the crane vessel and the shear leg then sailed to site. As you can see here, this is sailing to site with the load in the hook. Yeah, to location. Typically, you can see here the weather was smooth, but that was definitely not always the case. Here we see the same with the more conventional derrick barge with the load in the hook. Here we see the foundation, the substructure, the turbine foundation jacket being lowered into the water. And here we see a snapshot of the sequence of lowering it to the seabed. Yeah, and this is the final installed condition. And here, for sake of good measure, yeah, we see the turbine being installed on top of the foundation jacket. Yeah, and this is done typically by a jack-up installation vessel because of very accurate verticality required for the turbine and installation accuracy. So minimum you cannot afford any movements on the vessel, and that's why they use a jack-up solution. Here we can see a quick snapshot. It took us about, if you look across these 11 foundation jackets, yeah, it took us about between 8 to 31 hours to install each jacket. Yeah, which is incredibly fast. And for good measure, yeah, please remember that the jacket weight was 13 to 1800 tons. So these are not light structures. Yeah, these are significant structures. But it took us, as you can see, for location B03 to location A02, anywhere between 8 to 31 hours to install the entire jacket. The second project I want to share with you is the Offshore wellhead platform in Malaysia. This is an oil and gas structure in 73 meters of water with a 320-ton topside, boat landing, a jacket weight of 1,200 tons, 3 conductors, and suction piles with 6-meter diameter and 14 meters length. So it's probably a bit of clayey soil, because in clayey soils you have a typical length which is about 2 times the OD. So this was in Malaysia 2017. Here we can see the installation snapshot, the Offshore jacket, a tripod jacket, conventional tripod jacket with suction piles arriving on location. Again, we used a shear leg for this operation because it was a very cost-effective solution using the shear leg. On the top right, we see the as installed situation after the deck has been installed. Here we see a little bit more of the jacket lowering into the water, but more importantly, on the right, bottom right, you can see the flywheels, the umbilical wheels. These are the three umbilicals connected to the suction pumps on top of the suction piles, and this contraption is installed on board the offshore installation vessel. Here I will show you a video in a minute. Here we can see a snapshot from the control cabin, lowering of the piles into the seabed, set down, self-penetration, as you can see, and the bottom section, bottom part, you can see so-called uneven level, and that is relatively easily controlled by just lowering one of the tripod piles to achieve perfect leveling. So it's a relatively easy process. The whole operation for Offshore installation here in Malaysia with a shear leg was scheduled from start preparations to go ahead for liftoff until topside installation completed. It was scheduled for 81 hours. We actually did it in 80.3. So the actual duration time, installation time, jacket, boat landing, topside was 3.35 days, actual installation time, 3.35 days. In 2019, Offshore then realized, or Vestigo, the owner of the field, operator of the field, then realized they had a problem. They had a well problem, and they shut in the field, the well. But because it was installed with suction piles, Vestigo then approached the SPT if we could possibly relocate the platform for them. I must say that the initial plan was not to relocate by Vestigo. They just selected suction piles because it was the most cost economic solution for them. But because they used suction piles in 2017 to install, it became possible to relocate. So we had to do some modifications to install 1 or 2 additional lifting points on the jacket and the top side, because now you're lifting the entire platform, including the top side, yeah, to the new location. So you have a different center of gravity. So you have to do a bit of engineering, and we installed 1 or 2 extra lifting lugs. And of course, we wanted to maintain a 5% tilt during transit to the new location. So the new location was about 16 miles northwest to a new location called Jitang. And the shear leg lifted the entire, after we reinstalled the pumps, we recovered the piles from the seabed, then the shear leg lifted the structure out of the water, suction piles in the water, and then sailed to the new location. Tigor, shall we play the video? Hello?
Go ahead.
Play the video, huh? Hold on. I have to. Okay, well. Oh, hold on. No. The video comes at the end. Sorry. Sorry. Yeah, no. So there will be.
Better with the.
Yeah, I will have 2 slides very quickly, and then we go to the video.
Correct. Good.
Okay. Here a quick snapshot of a self-installing suction pile solution which we installed with a cargo barge. This was a Shell access riser tower in the North Sea for Shell. As you can see, we did it with a cargo barge, and no heavy lift vessel was required. Here we see the same impression, a minimum facility with monopod with 3 suction pile cans. Here we see our SIP2 concept, yeah, which is completely integrated in the yard, the legs and the topside integrated in the yard. It's loaded out in one piece, sailed to location on a transport barge. Offshore, the legs will be lowered. The suction pile legs will be lowered into the seabed. And then the substructure will be jacked up to design elevation, free of the cargo barge, and no heavy lift vessel required. This can be used for CPP purposes, but also can be used for smaller solutions. Here we see an actual project, an SIP project in progress, and on the left, top left, we see the end result as installed. So in summary, it is a very proven, robust technology, yeah, 23, 24 years by now. Since 1997, we have a lot of experience, over 600 suction piles. Suction piles suitable for greenfield, brownfield, minimum disturbance to the environment, fast and safe offshore installation. Suction pile solutions are suitable for minimal facilities, lightweight facilities, and conventional facilities. We have no immediate restriction on topside weight. We have a proven track record of platform recovery and relocation. We can demonstrate significant EPCIC cost savings. It's a clean decommissioning process, and it can be installed, relocated, or decommissioned either by a fixed shear leg crane or a conventional derrick barge crane, and of course, climate friendly, reduced carbon. And now, allow me to play the video for you. This is the Offshore wellhead platform that was installed in 2017 and that was relocated in 2019. Please enjoy.
Today marks the beginning of the Offshore wellhead platform's next chapter as RedTech Offshore and SPT Offshore teams prepare its relocation 60 nautical miles west to the Jitang oil field.
Yes, the project comprises the relocation of the Offshore platform, which SPT has installed 2 years ago. The platform comprises a wellhead platform with 3 conductors. It's about 1,400 tons in total weight, dry weight, and it's installed in 70 meters of water depth.
Beneath the waterline, an ROV guides individual suction pumps to the piles anchored to the seabed, securing them in place to receive umbilicals that are yet to be deployed. After its 3-day voyage, the Singapore outbound heavy lift vessel Asian Hercules III arrives at Ophir. Descending from the control container on board the ship, 3 lines of umbilicals are lowered and connected to the pumps on standby for activation at a moment's notice. At topside, preparation for the lift continues. A pair of lifting slings suspended from the ship's fly jib hook is manually attached to the pre-installed rigging lines. Meanwhile, the main hook rigging has descended into the water to the pad eye on jacket leg 1 and fastened. All lines are now secured to the heavy lift vessel and the retrieval operation can now commence. With the pumps activated, overpressure is created in the suction piles, their grip decreasing as internal pressure increases. Simultaneously, the rigging lines above are pulled and the combination finally releases the piles from the seabed. The raising of the platform is a controlled procedure. The piles are deliberately left submerged to prevent the platform from swaying, while a gentle 5-degree tilt ensures minimal drag during the voyage. Once hoisted to its transit height, the platform is ready for departure. All systems are go as the ship leaves the vicinity, charting its westward course to Jitang. The journey takes approximately 36 hours. The Jitang field 70 nautical miles off the Terengganu coastline, less distant than its Ophir counterpart. It is 9 a.m. when the vessel and platform arrive at their destination. The CSB is already on site, its crew briefed on the tasks ahead. The process of installation is about to proceed. In its new surroundings, the platform is maneuvered into position and precisely oriented before the jacket is slowly lowered. Once the platform has attained self-weight penetration, the pumps are reactivated and the suction operation commences. Over the next 2 hours, the piles would entrench themselves deeper into the seabed, with the remotely controlled pumps leveling the structure until the target penetration depth is achieved. Stabilized and fully adhered to the sea floor, the platform relocation is a resounding success. With the lifting slings detached from the structure, the CSB commences its completion work. From rigging removal to cleaning, to the reinstatement of topside, the platform is restored to its original condition. One whose viability in offshore production beckons a bright and sustainable future. SPT Offshore, performing under pressure.
Okay, Pa, over to you.
Well, thank you very much, Sergey, for your very nice, interesting. You already highlight the key element of this suction pile. You indicate that the control cabin is the pump, and also the limitation on the soil condition. You already indicate which one is not suitable and is considerable, and for good condition. So you show also the typical suction pile which used for platform for decommissioning. So I think it's a good thing for if we design from the beginning is with the suction pile, the benefit is in the future that we can relocate with easy for structure installations. My understandings in the API itself, because API is referred to the Gulf of Mexico, which considers a harsh environment, where if you try to find the word of suction pile in the API, you will not find. Yeah, so there's no such success pile in the API. That's why maybe in mind of the structure engineers, that's quite reluctant to use this suction pile on the platform. But in fact, as you saw, that is considerable for the minimum platform. Yeah, let's say that triple platform with certain weight and then certain water depth, and then in the benign condition, that's workable to my understanding. So that is very interesting. All right, ladies and gentlemen, that's a very interesting presentation today. I think we have already many questions here, so I can maybe read for you, Seiji. And also, there is still another session at the end of this presentation. We will have a quiz. Yeah, there is a good token from SPT. Yeah, that's I choose last time when CJ offered what is the right token, but I choose drinking a bottle. So that will be good one, and that will be used for the engineer. So I encourage all participants to raise questions. You can write in Bahasa in the chat area, or you can show me in raise hand if you want to talk. Yeah. For now, I have about 4 questions here. So maybe it's actually the answers already from your slide. But if you want to give an answer, I don't mind. So I can read you the questions. The one is from Mr. Joko Kristiono, my fellow in Singgar Mulia. So basically, Pak Joko want to see the installation of the suction pile, especially for the appending, because mostly we understand the appending process for sort of a jacket. So maybe you can explain in case that jacket is already integrated with the suction pile. So there may be a limitation to do the appending. So we have to have right equipment. And the second question is from Pak Humisar. This is my colleague and lecturer in the St. Thomas University in Medan. So this question is about the suction pile can be applied with the jetty structure, which is say 4.5 kilometers away from the source. That is his question, whether it can be applied to the jetty structure. I think that's the first, second for you to answer, and the rest I will give you for the next session.
Okay. Selamat pagi. Oh, tengah hari already. Oh no, it's 11 o'clock. Tengah hari in Malaysia. So, hey, Pak Joko, nice to meet you again. Thank you for participating today. Yes, on the issue of appending. Yeah, it depends on the installation vessel. Yeah, and it depends, of course, on the water depth. Yeah, typically for up to a certain water depth, I think somewhere between 80, 90 meters, the shear leg can upend the structure without the need for buoyancy tanks, because the shear leg can do an upending in air. Yeah, we just need to be careful that there's enough clearance between the boom and the top of the jacket. A typical derrick barge, even though it may be a 3,000-ton revolving crane, may not have that capacity, and they may need to put the jacket in the water. In other words, you may consider some buoyancy, added buoyancy, to make sure that the jacket is free floating during installation. So a derrick barge can typically do the upending in air. Yeah. So and a derrick barge, even up to, depending, again, it depends on the water depth, on the length. Lower water depths, the derrick barge can do a double block upending. Yeah, in air. Larger water depths, they may put it in the water first and then upending in the water with the 8 buoyancy tanks, Pak Joko. So I hope that addresses your question. Yeah, I don't have a video at this point in time, but I know where to find you. So if I can find a video or a schematic, I will send it to you.
Thank you, Pak CJ.
Welcome. Welcome. The second question, I missed the gentleman's name. Your
Humisar Pasaribu.
Okay, Humisar.
Hard for you to do.
Yeah, Humisar. Okay, Humisar. Okay, you asked the question of can suction pile technology be deployed for building of jetty structure? Again, it depends on water depth. Yeah, if because I showed earlier that suction piles in less than 10 meters of water depth may not be the best solution, technical or cost-wise. Yeah. If the jetty is in if let's say if the final section of the jetty is in deeper water more than 10 meters, then yes, we can come up with a technical solution, and then we need to do a commercial a cost evaluation on the viability, the cost viability of suction piles. So below 10 meters of water depth, probably not a good idea. More than 10 meters of water depth, we definitely could have a look at it.
Okay, thank you, CJ. So I continue with my the question. There are a lot of questions coming here, so I just summary about the question. One in general is about the soil. I think you already saw in your presentation, but the guys still asking about, especially for the sand. Yeah. So this guy is asking what is the limitation condition for the sand soil to do this presentation. And in another terms, guys also asking about effect of soil properties, but maybe his question is about what is typical of soil that suitable for this suction pile, right? And other question is quite specific. He's asking about the suction pile performance for seismic design compared to the driven pile.
Okay.
Other things also.
Yeah.
Okay, go ahead.
Okay. The first question was about soil conditions, right? Hold on now.
Yes, right. And this is also the question also regarding the soil disturbance, because in case, let's say that we have a wind turbine or rigs, there will be coming rig later on around that will be spatkan around. So there will be a soil disturbance on the suction pile. So what is the consideration? What is the effect? What is the requirements to avoid the issue of soil disturbance?
Okay, we let's address the soil conditions first. Yeah, if you look at here at the screen at item 5, the penetration depth for a typical suction pile, maximum penetration of depth is related to types and type of soils and water depth, of course. Suction piles are very suitable in sandy soils and clayey soils or any combination thereof. Yeah, we've executed 6 platforms projects to date in Malaysia, and typically the soils in Malaysia are suitable. From what we have seen in Indonesia so far for the various studies and inquiries we've had, the soil conditions in Indonesia are equally suitable. Yeah. Again, the typical values for suction piles in relation to jackets, if you look at item 5 for sandy soils, we have shorter lengths. Yeah, the length of the pile is typically equal to the outside diameter. For clayey soils, you have a bit longer piles. Typically, typical figure is twice the outer diameter of the suction pile. Yeah, but as you can see from the note, this is indicative only because if the top layer consists of liquid soils, then the piles could be longer. So the suction piles are very suitable for sandy soils, clayey soils, or a combination thereof. I hope that that addresses your question. Then, Tigor, what was the other question? Oh, about the interference with the spud can for the drill rig. Correct?
Yeah.
Yeah. Okay. I do have somewhere a schematic, but suction piles and are of course in our design we consider the future use of the drill rig. Yeah. The suction pile principle compared to a spud can principle is slightly different, so you cannot compare the two. But typically, we can design a suction pile solution that does not interfere with the footprint of the drill rig. Yeah, because of course this is our bread and butter, and I will maybe I will send the drawing to Tigor, and then he can distribute after this meeting. But typically we design when we design the suction pile solution, yeah, we do that with the potential drill rig in mind and the spud can footprint to avoid interference. Was there another question, Tigor?
No. About the seismic performance of the pile compared to driven. That's
yeah, good one. Actually, and I now have to tap into my memory. Suction piles are actually suitable for seismic areas. Yeah. Now, I do lack the technical backup to tell you why. Yeah, and I'll make a note of that because we had that question previously from an Indonesian participant in one of my presentations or email correspondence. But because of the shallow, relatively shallow foundations, the suction piles are typically more suitable than driven pile solutions for seismic solutions, yeah, in seismic sensitive areas. So, but I need to come back on exact details because I'm not technically sufficiently qualified to answer that in detail. I do remember that we have addressed this question before in relation to Indonesia, and the feedback from my engineers was that suction piles are definitely suitable for seismic sensitive areas. But again, it all comes down ultimately to input and engineering. Yeah.
Okay, good one. All right, let's see other question. This is a lot about technical. Once guys ask also about the thickness of this suction file, yeah, the thickness of suction file, and there is a question from the participants about, in particular for the analysis. He's wondering about the analysis method for in place, let's say for the holding capacity of the SPT for suction pile design. I think this one is almost the same for the driven pile, but maybe you have any more explanation for the analysis method for the in place analysis of the suction pile.
Yeah.
And
yeah, go ahead. Go ahead.
Go ahead, and I can repeat for you. No worry. No. Just
Okay.
answer.
The in-place analysis, yeah, is something that we typically do, of course, for every for every tender, for every pre-feed and feed study. Yeah. Now, if you ask me the exact engineering codes and programs used for this, I have to come back to you. I know I have addressed it before, and I have somewhere in my files, but I can't tell you from the top of my head which particular design codes or programs that we use. But I can definitely give you an answer via Tigor by email. After I look up the information. That was in place analysis. What was the other one?
And the thickness of the suction pile?
Yeah, again, the thickness is a little bit, again, you're talking about 20, 30 millimeters probably typically, but we also look at local fabrication capacity. If we can design it to make it suitable for local fabrication capacity in terms of wall thickness and rolling capacity. So yeah, but it is in that order of magnitude. If my
Okay.
my technical skills don't let me down here. Yeah.
Yeah, no worry. That's I mean the thickness is depends on the capacity and the strength. So it ranges from maybe 20 mm to up to 50 and so on.
30 mm. Yeah, I mean,
And there is
yeah. Go ahead.
There is a question quite specific maybe about the installation itself, because this guy is basically wondering the how to say the technicality of the installation process. So this guy asking if the subsea structure with the suction pile foundation is asking, does the constant tension needed from heave compensated crane? Okay, but I just can read this one while sucking out the water out from the pile. You can clarify that?
Yeah, I think I understand what the question is. No, there is no constant tension required. In fact, after, of course, we're talking about potentially two scenarios here. One is installation, one is recovery, relocation, but focusing on installation first. When the crane vessel lowers the jacket to the seabed, and we have self-penetration, yeah. Once the cell penetration is complete, the installation vessel can slack the rigging. Yeah, so there is no constant tension required at all. Not during installation. And of course, you know, you can keep a bit of tension on the installation on the lifting slings, but it's not relevant to the suction pile installation process after cell penetration. So. No constant tension required. During recovery, when you reverse the process and you create overpressure inside the pile, again, it helps if the lifting vessel keeps tension on the slings and pulls a bit, but it is definitely not a matter of muscle, of crane muscle, because the suction piles and the suction pump and the suction pile process can release the suction piles by themselves. However, it's of course during this process it is recommended that we keep the slings how to say tight and not slack, so that the crane vessel and the suction pile release from the seabed happens in a controlled, smooth and gradual process. Yeah, so maybe it's a little bit more applicable to recovery relocation as opposed to installation, but it does not require a constant tension crane or winch. No. Okay.
All right. That's the coming question also here, yeah. So I can read from Pak Setiawan, Pertamina. So this is in general terms, maybe I already seen from your slides. So we are talking about the limitation of the crane vessels. As we see that mostly your suction pile is attached with the part of the jacket or substructure. So in case that we have limit the height, total height of the jacket, and the suction pile is over the crane hook height. So is it possible to split the suction pile, the jacket structures, and what is the considerations from design and installation?
Yes, if during my presentation, I showed a slide on the split jacket concept. Yeah, the split jacket concept can benefit in a number of ways. For sure, for somewhat lower, smaller water depths, it could a split jacket solution could potentially allow for installation by the drill rig. Yeah. That is one option by the jackup by the drill rig. If we come up with a split jacket solution, again, as I said, the shear leg, because they are based out of Singapore, are available in this region, so that is positive. But of course, given some of the cabotage laws, local requirements, local restrictions, I may not always be able to use. So then we have to look at available crane capacity in the region, yeah, for certain water depths, and make the design suitable for as many domestic offshore contractors, offshore installation contractors, to create a playing field for the end client. Yeah, so not to be dependent on one single vessel. That's always difficult. So the split jacket concept allows for smaller crane capacity, be it a jackup rig, be it the smaller crane barge, be it 1,000 ton, 1,500, yeah. To participate in terms of lift capacity and lift height. Yeah, so that will definitely be a consideration in the pre-feed and feed approach. What are the local requirements? What are the local restrictions? Yeah, and what is the preferred installation method? Okay.
All right. There's still questions about the soil settlement. So I summary the question.
I have one here.
So the part, yeah, that Ibu Sofia Kangen asking about the soil consolidation over time, and when we have to remove the platform, what would be the problem, or how do you anticipate this when remove the jacket from the site during the decommissioning? So I understand that due to the settlement, that soil capacity is going up, right? So that we have to anticipate is more than when we do installation. So I think you can give the answer to that. So another one before, okay, that's about 10. The guy asking about the PLM foundation, which may be normally used in the seed pile, but he's asking what is the comparison of the seed pile to the suction pile. Okay, so he's also asking about the seed piles. He's asking about the PLM foundation, right?
Yeah. Okay. Sheet piles.
For the PLM foundation, yeah, using the seed pile. So he's asking now what is the difference of compare the seed pile with the suction pile concept. And further to that, he's asking about the pull out capacity of suction pile. Yeah, because we are talking about installations, but this guy is asking about the pull out capacity. Yes, more analytical. Is it depend on the soil friction or pile weight, and whether the soil material inside the pile can function as a gravity base?
Okay, first we'll talk about the settlements. Yeah, if you look here at the screen, item 8, yeah, we do get that question on a regular basis, and that's why I put some typical Q&A. We do calculate long-term settlement based on soil data. SPT has a number of very experienced geotechnical engineers in our headquarters, because that's our business. Yeah, so they have seen based on 600 suction pile foundations. They have seen many have a large inventory of soil data, of course, globally. Yeah. So yeah, we do calculate long-term settlements against any given requirement on the settlements. And where required, we, as it says here, we make our design. We design a bit longer piles, yeah. But as over the last 25 years, we've installed some 600 suction piles without any failure or remediation work required. Yeah, because often people worry about settlement. But it has never been a technical problem in the history of SPT. Typically, I put a note there, yeah, because even in the extreme and unlikely event where a platform could possibly tilt after installation, yeah, let's say it happens. It hasn't happened before, but let's say it happened. Then we could fairly easily rectify the out of level in situ by simply mobilizing 1 or 2 pumps on a supply boat. Install the pumps and simply lower either raise one of the piles or lower another pile. But as I said, this has never happened before. So even if there's settlement, it can be fairly easily adjusted, rectified. Yeah. And what was the other question, Tigor? About sheet piles. Yeah. I have no personal experience with sheet piles, to be honest, so I'm finding it difficult to answer that question. I know you did your introduction, Tigor, on the included sheet piles, but it was in Bahasa, so I was trying to learn, but it didn't work for me. So I can't really say how I will look into it, and I will separately address it. But at this point in time, I cannot give you an informed answer on the pros and cons of suction piles versus sheet piles. My apologies. Was there any other question?
Okay, good. Yeah. So there is, maybe I can read 1 or 2 technical, but there is one still about the commercial. I put it to the end. No worry, because we address also for the first for the technical. So this guy asking about the stiffeners on the suction pile. Okay, I understand it's basically about the connection of the jacket to the suction pile, but this guy is asking, is it a temporary to ensure the stability of cell or permanently stiffener and left after installation to ensure the stiffness of large diameter pile like suction pile and improve resistance of suction pile, or it will be removed prior to installation, appending them to suppress. So I think you need to explain to us especially the connection of the suction pile to the jacket at the top one. I understand there should be reinforcement there. So this guy's thought is like installation aid, or that one is any purpose for improvement of the capacity. And is it leave it there, or is just installation guide to remove later, right? And
yeah.
Okay. And this guy is asking how long the suction pile will resistant from any damage from natural, and how to mitigate this situation and condition. I'm not really clear what it means. How we know that material of suction pile system is in a great condition? There are many certifications from authorized institutions or kind similar. Okay, if you have any idea, you can share about that. So.
Well, again, as I mentioned in my presentation, the design life of a suction pile and a suction pile substructure is exactly identical to a driven pile conventional solution. Yeah, so there's no difference in design life or in quality of the foundation piles. Again, after 25 years of operation, we have not encountered any problems with any such problems with suction piles. how a client would monitor the quality of the suction pile below the seabed, I have no idea. I can't give you an educated answer on that. Yeah, but other than the typical anode protection, I guess, yeah, that's all I can think of. It's very similar to a driven pile jacket. Then the second question, in terms of stiffness, how is the connection between the jacket and the suction pile? It's a welded connection. Yeah, I mean the top plate of the suction pile is equipped with a stiffener arrangement. This is all designed by SPT. Yeah, the detailed design of the suction pile, including the jacket pile connection, is designed as part of the pre-feed study by SPT. So we typically the cutoff point, the battery limit for a design scope is maybe 2-3 feet above the pile jacket connection. Yeah. I do have somewhere in my archive a drawing for that, but I would have to look for it. And again, I will happily share that with Paktio, so you can. I don't know. Does it make any sense for me to send some answer after the meeting? Do you have the email addresses for the participants?
That's possible. That's possible.
Yeah. Okay. Then I'll try to dig up as much. Yeah, so typically we design the connection between the pile and the jacket, and yes, it's a stiffener-based solution, a welded solution, and that is within our design scope, and the battery limit for the design scope is typically 2 or 3 feet above of jacket leg, above the connection. Okay.
Okay. So I think one more question for technical before the economical. So one of the concerns from the minds of engineers, I mean, in terms of practicality, it's not about the design. That is about let's say the uncertainties of the soil layer and so on. So there will be likely failure, right? So how do you anticipate this failure in case that we see from the geotechnical that is a good soil, but in fact that in reality is not, right? And then you have a pump, and maybe during the operation it doesn't work. So how do you address this uncertainty? Do you do any specific tests, performance, and so on for the tools and equipment and will be used?
Yeah, so I was afraid of very detailed technical questions during this session. Unfortunately, because of the time difference with Holland, I could not get one of our technical engineers to support me. Yeah, because it's that's a bit unfortunate, but that's okay. First of all, in 25 years of 24 years to date, we have not experienced any failure. Actually, we have experienced one failure in Mexico, where we couldn't get during the installation process we couldn't get under pressure in the pile, because it so happened that the edge of the pile was sitting exactly on top of a borehole. So in other words, we didn't have a sealed connection between the inside and outside of the pile. Yeah. So we couldn't get the required under pressure in the pile. So after we discovered what the problem was, we simply picked up the jacket, we moved it 20 feet to the right, and reinstalled the jacket successfully. Yeah, it is as simple as that. So to date, no failures. Yeah. Now, of course, it largely depends on the quality of the soil information. Yeah, that's why we say we do require representative soil data. After 600 suction piles, we have a large archive library of soil data, comparable soil data, and challenges that we have experienced in the past. So we can apply that. But again, the soil data for us doesn't have to go 50 meters deep. It is relatively shallow soil, so typically the soil information, if representative, is accurate. Yeah, we don't encounter a lot of surprises in the first 20 meters of soil, from our experience.
All right, good. I think this would be the last question for the commercial. So, Pak Widya Desmiardi asking about the capex. So, maybe have a figure. What is the commercial and the capital expenditure for, let's say, to design and install one suction pile in the range of water depth, let's say 30 meters to 50 meters, right? So yeah, maybe you don't have the detailed figure, but maybe we can have a rough figure. And he's asking also the cost saving if we compare with the fixed platform. In this case, I think with the driving pile. So I guess you have in your slide, but maybe we can elaborate more.
Yeah, so we typically, without going into any specifics, we typically indicate the potential for a 20-30% EPCI cost saving for the end client, yeah, by using a suction pile substructure design. Yeah, SPT does not get involved in the top side. That is so all we need is soil data and topside weight and loads. Yeah. But from a substructure perspective and a suction pile substructure perspective, we typically see the potential for 20-30% EPCI cost savings. Yeah, as showed in my presentation, the earlier slide, for a new build jacket, 4-leg, 45 meters of water depth, savings are potentially in a number, $3 over million US. Yeah, of course, if the jacket is in a larger water depth, these savings will increase. But again, it depends on local fabrication prices. I mean, I've been in this business now for 40 over years, and if I have learned anything, is that every project is somewhat unique. Yeah, be it because of soil conditions, be it because of water depth, geographical location, type of platform. There are many things, parameters to consider in achieving optimum savings, so to speak. Yeah, simple fact is that by default, a suction pile jacket should be cheaper. How much cheaper really depends on local conditions and parameters. Yeah. In order of magnitude, yeah, a detailed design for a suction pile jacket is probably around $1 million. Plus or minus 20%. Yeah. Sorry, no, the detailed design is less than that. Is $250,000 maybe for a jacket, for a single jacket. The offshore installation support services maybe around $1 million per structure. Yeah, plus or minus 20%. If you have multiple structures, of course, you get the benefit of scale. Yeah, if you have more than one structure, of course, it becomes cheaper. If you have 3, 4 structures, it becomes cheaper. So, but these are the order of magnitude numbers that you may have to think of. And much more I can't tell on the commercials at this point in time.
All right. Thank you, CJ. I maybe can add more to that. So as illustrations for this suction pile compared to conventional pile driving, as you see on the slide, that we have to mobilize the shear leg, right? This shear leg is particularly operated in Southeast Asia, based in Singapore. So we have to mobilize that one. But remember, unfortunately, that shear leg cannot install the pipeline. So you know, when we install the platform, we still need to install the pipeline. So we still need the bars to install the pipeline. And other issue, the shear leg has no accommodation, meaning that the personnel and also material for consumable hookups, you still need to bring over the, let's say, accommodation walk bars. So let's keep this in your mind. If we install by the suction pile, you mobilize the shear leg, you mobilize the pipeline bars, you mobilize the accommodation walk bars. That's a minimum, right?
Well,
because this accommodation bar.
But if you allow me, yeah, I mean, we do get discussions on a regular basis with our clients. You can look at it from two different perspectives. Our experience has taught us assuming that in Indonesia you can use a shear leg, yeah, but because I would assume that in Indonesia you would have to rely on the domestic crane or derrick lay barge or derrick barge facilities, yeah, that. And then you have to look at if you talk, for instance, about TMAS, which is a derrick lay barge, then you have to look at the crane capacity and make the design suitable for the crane capacity. Yeah? I'm just giving you an example. If you were to use a shear leg just for academic discussion, yeah, a shear leg we typically use in combination with a construction support barge. Now, people think that's expensive, but not necessarily, because the shear leg can be released from the site within 3 days. Yeah, and the construction support barge can do a lot of not only access accommodation, but typically they have a crane and they can do a lot of concurrent activities. Yeah. Now, by using a shear leg and a cheap, very cheap construction support barge, because they don't cost much, but you can release the shear leg, and then the cheap construction support barge can stay on site, finish the welding, finish all the appurtenances, finish the boat landing, and all that kind of stuff. Even do the conductors if necessary. Yeah. And by that time, the expensive, comparatively expensive shear leg has been demobilized already, and therefore your weather risk, yeah, in terms of cost exposure also becomes less, because now you only have a construction support barge on location, which is relatively cheap. But it also allows you, in terms of pipe lay, to select a much less spec pipe lay vessel, because typically if you use a derrick lay barge, you pay a premium. You always pay a premium, and even if it does menial work, small support activities, you still pay for the entire offshore installation spread. Yeah, but if you break it down into lesser spec vessels, so to speak, construction support barge and a smaller pipe lay barge, you will see actually, first of all, you have schedule flexibility. Yeah, you can disconnect the pipe lay campaign from the installation campaign. Yeah, and you can use cheaper solutions in terms of pipe lay and crane capacity. So it is not a straightforward black and white dialogue, black and white comparison. And that is my T&I instinct speaking.
Correct. So I just can give the illustration now, right? So if we talk about the conventional, we move direct laying bars. Yeah, that one can also install the pipeline. So that is, if you want to do the evaluation, that we just have a particular evaluation for this marine spread. Yeah, so that marine spread at the end of the day will determine which marine spread that we use, that we better understand the cost of installations, right? All right. Okay. Correct. So there are I think two technical questions here, but I think I can answer because this guy is asking about the soil friction capacity for the suction pile. It is the same with the pile driving. We can refer to API for the capacity, right? And other thing is asking about the natural period of the platform. I think though this CJ installed the platform, but the one who understand the natural period would be the structure guy. So for natural period of the platform in the water depth range 70 to 80 meters, depends on the typical of the platform. If it is 3 leg, that will be around 3 seconds, right? But if 4 leg, that be less than 3 seconds. So I think that's all the question from the audience. Yeah, I already read all on in the chat and in the QA chat. Yeah, so thank you for all your participation. Very interesting. Yeah, this discussion today. So now it is our turn to ask you with the question from Mr. CJ, and we will get the prize for the token for the correct answers, and you will get the token. There will be 5 questions. So I'll show you one. CJ, maybe.
But Tigor, before you go on, because I'm sure there's people out there with questions, please take down my email address and feel free to send me an email to if you have any questions remaining. Yeah, cjc@sptoffshore.com, and I'll be happy to address them. If I can't answer them, I'll get my technical team to deal with it. Yeah. cjc@sptoffshore.com. Okay, over to you, Pa.
Good.
So shall I stop sharing?
So emailnya adalah.
I stop sharing, yeah.
Wait a minute. CJC, your email address. Maybe you want to have to question. Just hold on. Or the email address.
Okay, hold on. Where is my? Okay, there we go. Hold on. There we go. CJC.
Okay. Yeah. So this is the email address. Please, if you want to capture, I give you a few seconds. Okay, thank you, CJ. Now we go to the quiz session.
Yeah, you have the question slide, yeah? Yeah.
Yes, correct.
Okay. Yeah. Okay, over to you.
Yes, I will share. I will share the one. Oke, Bapak Ibu, teman-teman semua, akan ada pertanyaan dari CJ. Saya akan bagi slide-nya. Nanti jawabnya di ini ya, di chatting ya. Kita menunggu jawabnya di chatting. Siapa yang duluan dia yang dapat ya. Oke, siap-siap di chattingnya sebelum saya munculkan slide-nya ya. Begitu saya munculkan slide-nya, tolong dibaca dan ditulis jawabannya ya. Jawabannya berupa A, B, C. Siapa nanti yang benar pertama itu yang akan dapat hadiahnya. Oke, saya mulai dengan pertanyaan pertama. Saya share dulu. Oke, here you go. Share. Have you seen the screens? CJ, have you seen the screens?
Yeah, I can see the screen. Yeah, clear.
Yeah, it's clear.
Okay. So we are waiting for the answer.
I see a winner.
You see the winner. Where is the winner? Chat. Check one. Sorry.
Am I supposed to give the answer?
Yes, give the answer is C, 600, right?
Yeah, correct. It's 600 suction pulse
600
to
is the
date.
correct answer.
1C, correct.
Oh, who is the guy? Who is the guy?
I
The
cannot see
first one,
already.
correct?
I cannot see you. What's the
TH.
Pak Baja, aku nggak.
TH. Namanya
Siapa?
DH, Bang. Nanti saya munculin ke panelis ya.
Oke, selamat ke Pak DH ya, Pak DH.
Iya.
Saya nggak bisa lihat. Oke.
Saya udah
Pak, selamat
masukin
atas
ke panelis.
Siap. Nanti akan dihubungi oleh panitia Pak Baja untuk dikirim hadiahnya ya. Jadi apa namanya, tempat minum SPT ya. Baik, kita masuk ke pertanyaan kedua. Stop dulu. Yang kedua siap-siap ya. Siap-siap yang kedua. Ayo.
yeah. Lama, there we go.
Who's the
Yeah, very fast.
Very fast. Who's the guy?
The correct answer is 1B.
Yeah, B. Who's the guy?
Papaya, I have to tell. I cannot say.
Yeah, I'm thinking. The correct answer is
I cannot.
B, ya?
1B, correct.
B,
Yeah.
1997. 1997.
Okay.
Who is the correct one?
The correct one is Gilang.
Gilang.
Yes.
Oke, selamat Pak Gilang. Congratulations Pak Gilang.
One bottle on the way.
Yeah, one bottle on the way. Oke, itu comes down ya. Oke. Alright. Oke, menunggu yang 3 lagi. Saya tutup dulu. Baik, kelihatannya semua mengikuti ya presentasinya dengan baik. Kita tes dulu yang ketiga. Seperti apa? Siap-siap jawabannya? Ayo. Iya, munculkah? Kok belum muncul ya?
Iya, belum muncul, Bang.
Belum. Oke, here we go.
Yang menjawabnya di kolom chat ya, jangan di Q&A.
Ini sudah muncul?
Sudah.
Next one.
Ini tadi kan?
Ya, ini yang tadi, Bang.
Next one ya. Ini stop dulu deh.
Ya, next slide.
Ini kok jadi... Wait. Ini yang ketiga. Oke, share. Sip.
Yeah, the winner is already on board.
Oh, congratulations. Who's the guy?
Which one is the correct one?
The correct one is 11. 1D.
11. Wah,
D.
They pay in particular questions, huh? That's good, yeah. That wind farm in Aberdeen.
Sorry, the correct one is
maybe
D, right?
D, yeah.
11.
Yeah, D for
Ahmad
Denmark.
Yajid.
Siapa?
Ahmad Yajid.
Ahmad, ya selamat Pak Ahmad ya. Oke, one bottle down gitu, delivery ya. Oke, so they really pay attention to your slide.
Yeah, good.
Oke. Alright, so ada 2 lagi Pak ya, 2 lagi.
Yeah.
Ini hadiahnya menarik ini, soalnya dari Belanda langsung hadiahnya, made in Dutch.
Now the next one is going to be interesting. Let's see.
Okay, alright. Here we go. The 4th question.
What is
Let's go. Correct one? No?
What is the maximum current water depth track record for SPT installed suction valve jacket to date? The correct answer is 104 meters. The track record.
104 for D, right?
Who is the guy?
I think it's
D, right?
1D, yeah?
The guy is same, DH. Pak DH menang lagi. Gimana,
No.
Bang? Mau
Wait. wait, CG cannot be the same, eh? Cannot be the same. Wait. No. CG already give the answer. So, okay, just go. Who's the fastest? Just type now. Who's the fastest?
The fastest is
You already know the answer.
Leha Bang. Tadi dia udah menjawab di nomor 1.
No, cannot be. No.
Oh,
You
oke.
say the other. No.
Oke.
Cannot.
Kirain Pak Renaldo. Sorry.
Renaldo. Oke.
Yes.
Renaldo. Oke, benar ya?
Ya.
Okay, congratulations, Ronaldo. CJ helps you to get the one. He already gives the answer. You are lucky. Okay, remind for the one who already get, please give opportunity to the others. That's what I'm saying. All right, man. Thank you. So this will be the last one. Yeah. So yeah. Okay. Please. Yeah. Please, the one who already get. Give the opportunity to the others. All right, man. And be ready to type. Be ready to type because Seiji watch you. I can see. Okay, now 1, 2, 3. Here you go. It's coming. Is it coming? CJ, is it coming?
Yeah, I can see the people answering, but let me see. I cannot. I cannot see.
Moderator bisa dikeatasin soalnya D-nya nggak kebaca, Bang.
Can I give the correct answer?
Yeah.
No, not
yet.
No, CJ. Please, CJ.
Not yet. Okay.
No, not yet. Wait. This is the last one.
Yeah, last question. Last drinking bottle.
Yeah. I have
last SPT drinking bottle.
Okay. Wait. Okay. Sorry, this is the last one. Wait a minute. I have a technical problem a bit. Okay, here you go. I open. Okay. Now. Where's the one? Oh, why I can't see? Okay. Can you see this one?
Yes.
Okay. What is the correct answer?
Bang,
correct.
Belum dimunculin, Bang. Bisa diklik lagi?
The correct answer.
Belum muncul.
Belum muncul. Bisa diklik lagi?
What's the problem?
The answers are still coming in, thick and fast.
Already?
Not, Bang. Screen-nya belum muncul.
Wih, kok bisa ya? Ini error ya?
Bang Tigor, Mas, coba.
So, can I give the correct answer or not?
Wait, not yet. Ini udah kelihatan?
Yes.
Ini udah kelihatan?
Yeah.
Okay, so please.
The correct answer is 1B, 3.35 days.
3.35 days.
Okay, good one. Who's the guy? Who's the winner?
Okay, I'm checking. B, right?
Who? B, 3.3.5 days.
Correct.
Oh, is it? 1 minute.
Who?
The name is not coming. It's not shown.
Okay.
Pak Tigor, can you read the name before Pak Wahid?
Wait. There's no question. Di kolom chatnya kok nggak muncul sih? Wait.
Ini Bang, Aisyah
Ada?
Bang.
Aisyah ya?
Ya, Aisyah Anggra ini.
Oke, selamat Bu Aisyah. Congratulations ya. So that's all the token and the questions from the CG from SPT. So congratulations CG. All the participants can give all the correct answers to you. So I think they really appreciate your presentation.
The pleasure,
So
was
that's
all
all,
mine.
guys.
Wow. Wow.
Bang, ini saya udah
Almost on schedule. Almost on schedule, Pak.
Bang Tigor, ini saya udah munculin ke panelis. Mungkin kita bisa foto bersama, foto yang menang, Bang.
Okay, go ahead. So, okay, please open your video, gentlemen, ladies and gentlemen. So
Others
you take a photo session.
have the answer, the correct answer.
Pak Widya and others, please. You are invited to this panelist, so appreciate for you open your video, then we can take the pictures, the photograph.
Ya,
Now
Pak
it's okay,
Ahmad, Pak Ahmad Jajid 2. Om Renaldo ternyata ya. One more I think. Pak DH ya, mungkin belum. Oh, Pak Dani, silakan Pak Dani, kalau nggak keberatan bisa munculin videonya.
Pak Bumisar jawabnya benar tapi telat.
Ya, Pak Dani mungkin berkenan menampilkan videonya.
So we apologize for the participant in case we are not correctly pick up the fastest one. Maybe there is something wrong due to IT. We have to apologize.
Ya, mungkin segini aja Bang. Dulu kita ambil picture dulu Bang.
Okay, so CJ, make your smile.
Yeah. I will count until 3 ya. Smile please. 1, 2, 3. Yeah, thank you.
Ada.
Ya.
Oke.
Silakan Bang, dilanjut.
Okay, thank you very much for gentlemen for your attention and for your time. I think it is a bit dragging for 1 hour, so we're actually exceeding our time. So thank you. You're still be here. That's very interesting discussion. If you found any further clarification, you have already email from the CJ, and CJ and us is ready to help you. I mean, Pak Bagja in Garin and me in IAFMI. So I think all of us are ready to assist you, and we are welcoming you for the next training, especially for Garin already indicated in the slide, and also for the IAFMI we will have a plan for next future to do the other presentation for other subjects. So thank you very much, Mr. CJ, for your time, and thank you, Pak Bagja, and thank you all the audience, all my friends out there. So nice to see you. Hope to see you in other times. For now, thank you and goodbye.
Yeah.
Thank you everyone for your patience and participation, and have a good weekend. Safe weekend.
Thank you, Pak Tigor. Terima kasih banyak. Thank you, Mr. CJ. Weekend ya.
Thank you for the opportunity, and everybody stay safe. Goodbye.
Ya.
Jumpa lagi.
Ya.
Jumpa lagi.
Ya, rekan-rekan semua, kita telah sama-sama menyaksikan webinar dari Pak CJ, kemudian juga dimateri oleh Bang Tigor, dan terima kasih banyak kepada para panelis terutama, kemudian juga kepada para peserta yang telah berkenan untuk meluangkan waktunya di waktu weekend ini untuk ikut sama-sama bersama kami di webinar tentang section file. Semoga kita bisa berjumpa lagi di kesempatan lain dan juga tentunya bersama IAFMI juga kolaborasi selanjutnya sama CJ juga mungkin. It is not goodbye ya CJ, but it is you again. So akhir kata.
I hope so. I hope so.
Yeah, hopefully. Oke, semoga kita juga bisa melewati masa-masa pandemi ini yang sulit dan selamat sampai pandemi ini selesai. Akhir kata, dengan mencintai infrastruktur Indonesia, kita mencintai Indonesia. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Waalaikumsalam, Pak. Selamat.
Waalaikumsalam. Bye-bye.
And meeting semua.